Yes, good morning all. Let us begin with the discussion that we had done yesterday. I hope I have seen your submissions of the assignment. Okay. Let me just go through very quickly how I can implement the linear queue implementation using structures and pointers. Okay. I think there are how many people who have submitted. Let me check. 40 people have submitted the assignment. Okay, you just can see it. Okay, 40 people have submitted the assignment. Rest all have not submitted. Among the 42 remaining, 41 remaining, few people are faculty members. Okay, I'll not expect anything from them. So anyways, let us just quickly move on to the implementation part. Very quickly I'll be covering this and then we will be going ahead with circular queue today. Okay. So by the end of this coming week, before your second IA, I'll be completing queues chapter. Okay. And the portion for the IA, according to me, I have not discussed yet with Rangnath sir. Uh, Portion for IA, second IA will be stack and queue. Okay. Questions on stack and questions on queue. Okay. Accordingly, we will just proceed ahead. Let me just quickly finish off this program in just 5 minutes. I have given structure by name Q, okay, and then let me just 1 minute. Let me just copy this into some other file. Or else okay, C program to implement linear queue using structures and pointers. Okay, so accordingly, let me just go ahead very quickly. Struct queue semicolon at the end. Then I will have int q of some size, comma, you can give in the same line front, comma, rear. Okay, then let me just hash include stdlib.h, hash define size as say 5. Okay, then in the main, let me just declare struct q, take q1. Then I'll require element, comma, choice, comma. Okay, let me just have element, choice, and what else I may require. Okay, that's it. So then for with infinite loop, inside this for loop, for with inside infinite loop, let me have printf linear queue /n, then printf. Let me write a different choice here. Okay, I or capital I for insert. So choice is of type. Let me just unlock the meeting. Please give me time for that. Okay, so for the choice I will take character here, because look at the kind of choice that I am giving. I for insert, okay, then D or capital D for delete, and then display say play, P or capital P for display or print. Then printf, enter your choice. Scanf, %C, comma, ampersand choice. Then pass that to switch. See, purposely I have done the different kind of choice writing. Please know about it. I have done purposely. I have taken character choice here instead of integer choice. Case I colon. Look at the way I am writing. Case capital I colon. If Q1 dot rare equal to size -1, printf Q overflow else call the insert function insert underscore LQ in bracket Q1 semicolon. Then yes, anybody can comment what is missing in the program that I have written.
Q1, ma'am, as returning variable.
Q1.
Ma'am, Q1 equal to, ma'am, that function call.
Yes, okay. So when you go ahead in writing the things, Q1 you have passed as a normal variable. When you pass it as a normal variable, the updations done in the front or the rear, that will never be updated in the main. So what I need to do, I have to return that back. If you are not using pointers, you have to return that back. Okay. So before that, printf enter element to be inserted. Then scanf %d comma ampersand element. Please try doing this in parallelly if you are not done it. Okay. Then I have called insert function, then the break. Then I have case say second one D colon case capital D colon if Q1 dot front greater than Q1 dot rear, then printf Q underflow. Okay. Next, else I need to delete the element, and when I am deleting the element, the updations will be done. Okay. Okay, guys. Please, can you comment, all of you? Can I directly write with pointers? Please comment quickly. Can I directly use pointers so that it becomes convenient for me instead of returning the structure? Yeah. Okay. So what I will do, I'll remove this and pass this with ampersand Q1 comma element. Okay with this? Then in the else part, what I need to do, I need to call the function delete, and delete function will return me the deleted element. So let me write element equal to delete underscore LQ of ampersand Q1 bracket close semicolon. Okay, and I will printf the deleted element equal to %d/n comma. Okay, let me close this chat window. comma element semicolon. Then break from this case. Okay, then let me just go through the next case. Case small p colon, case capital P colon. Okay, in both the cases I have to call the function display if q1 dot front greater than q1 dot rear, printf q is empty. Else call the function display underscore lq of q1. This doesn't require pointer because there is no change in the front and the rear. Okay, then break. Then I will have default. In default I'll call exit of 0. Okay, then there is end of the switch, end of the infinite loop, then return 0 and end of the main. Okay, then I will populate the definitions of different functions. First function insert doesn't return anything, void insert underscore lq of struct q star q1 comma int element. Okay, I have already checked the queue overflow. So next thing that I will do is can anybody comment in the chat what is that I need to write? I'm waiting for your comments. What is that I need to write? Okay, q1 arrow rear plus plus. Let me write that. Why arrow? It is just because q1 is a pointer. Then I will write q1 arrow q of q1 arrow rear equal to element. Yes, you are right. Okay, you are right. Then once I have done this, whatever changes that are done that are also reflected in the main, you can combine these two statements into a single statement as commented by both Aditi as well as Praveen. Okay, then let me write int delete underscore lq of struct q star q1. Okay, then next thing that I will write is return. I'll combine all the things. Okay, q1 arrow q of q1 arrow front plus plus outside the bracket semicolon. If you want to give brackets here, you can give, but plus plus will be taken without any problem even if you don't give any brackets. Then I will have void display underscore lq in bracket struct q1. Then let me write for q1 arrow front, q1 arrow front less than equal to q1 arrow rear. It's not for, it's while printf %d /n, comma, q1. What is the mistake I have done here? Can anybody comment? Yeah, it's a dot, not an arrow. 100% correct, Indu. Because q1 is not a pointer here, it is a normal variable. Okay. So only in the display function it is a dot. q1 dot q of. Yes, what should I write? Correct. q1 dot front plus plus. All of you are getting whatever I have written? Semicolon. So this is LQ underscore implementation LQ using structure. Okay, any doubt in the program that I have typed? If not, I will go for the next one. Any doubt?
Ma'am.
Yeah.
Ma'am.
Yes, go ahead, Ajay.
Ma'am, please, can you please explain line number 16, ma'am?
Line number 16. Okay. This one, element inserting. Ajay, is it line number 16 that is insertion of element?
Yes, ma'am.
Okay. So how this goes on? I think I can explain this better by taking one diagram. Okay, let me copy this. And let me take a new window. Just give me 1 minute. Okay, let me paste this. And 1 minute. Yeah. And let me insert one table so that it becomes convenient for you to analyze the things. Okay. Now I have taken an array. Okay, this is 0th position, 1st, 2nd, 3rd, 4th, 5th. Okay. Now in the main, let me just show you the main where the function is called. I have selected, it means insert. Still the queue is empty, so it will go to else part. Enter element to be inserted. Say, let's say I want to insert 10 as the first element. So it has created an empty queue. Now q1 has empty queue, rear is equal to -1, front is equal to 0. Then element is 10 that gets passed. Okay, it will come to the insert function. Now I'll just change the window. In the insert function, initially q gets incremented. Q was -1. Now there is an increment of rear by 1. It means -1 becomes 0. At this point, both rear as well as front are pointing to 0. Okay. Then how can I access Q? How can I access Q? Let me just copy the structure for you. Just pay attention for this queue. Okay. So there is a queue available. This queue contains an array of some size, front and rear. So all these three can be made accessible only through the variable of the structure, not otherwise they are accessible. Okay. Then if I want to call front or if I want to call rear, if I want to use a queue, in all the three cases, I have the accessibility through the variable of the structure. In the insert function, which is the variable of the structure? Ajay, can you please comment? Which is a variable of the structure in the function insert? Yes, it is Q1. And Q1 is of what type? Is it a normal variable or a pointer variable? It's a pointer variable. Whenever you want to access through a pointer the member of the structure, you have to use arrow operator. Okay. And when I want to access any one member of the structure, be it Q, be it front, be it rear, I have to use Q1 arrow. Okay. So accordingly, in this line of code, if I want to tell that Q the zeros position has to be 10. Element available right now, element available is 10. Okay, element is carrying 10. Now Q1 is carrying 3 different members addresses. Q1, what it does, if I want to have the accessibility to this 0th position, how you can access the 0th position normally? If array is ARR, normally how do you access 0th position element? I will write ARR of 0. Okay. Similarly, that ARR is now called as Q, and I want to access any 0th position element, then I will write Q of 0. Similarly, if I want to access the next element Q of 1, similarly Q of 2. Okay. Then this 0, 1, 2 are available as part of what? It is available as part of rear. It is available as part of rear. But because whenever you want to insert, who holds the current position? The current position of the element to be inserted is held by rear. Okay. So this 0, 1, 2, whatever are there, they are nothing but the values held by the rear at that moment. So 0, 1, 2 are the rear values. Let me complete that first. In bracket, can I directly write something like this? Okay, let me write it in bold. Let me write like this, Q of rear. This is what you actually want. Ajay, I hope you are understanding this. Okay, actually I want Q of rear. Q of rear. But can you have the accessibility to rear directly? Rear is available as part of what? It is available as part of structure. Can you have the accessibility to the rear directly without having the key? Who is the key? Key is the variable of the structure. So what I will do? I'll update this rear with Q1 arrow. Why arrow? Normally, I will access using the dot operator. I'll just go back to the variable of the structure. What is the name of the variable? Q1. I will write Q1 dot rear. But Q1 is associated with a star. So dot gets replaced with arrow. Okay. Then in the whole line, let me write it as equal to element. Okay, I feel that I have done my part correctly. But actually, there is one more person who is inaccessible to you directly. It tells that directly Q is not available to you. It is available inside the box. You have to open the key for that. And who is the key? Key is Q1. Even Q is an array. It is also part of structure and it is a member of the structure. So can you have the accessibility to Q directly? No. How I can access that indirectly? Using the variable of the structure. And which is the variable of the structure? I'll just go back to this. Q1 is the variable of the structure. Normally, I will write Q1 dot. Normally, I'll write like this. But can you write dot? No. There is a star associated. So can you write dot? No. Dot gets replaced with arrow. So the whole thing gets changed like this. Any doubts? Please let me know. Okay. Any other persons having any kind of doubts? No doubts? Okay, Srinivas has a question. It's a very good question that you have asked. If we include element in the structure, okay, just have a look at this. What he is trying to tell, I will put element also as part of the structure. See, the members of the structures are to be so much that they are useful everywhere. They are useful everywhere. See, when I declare element over here, see, obviously you can declare element over here and you can call element wherever you want. That's 100% sure. But element will come into picture only when you are doing your insert operation, and only when you are doing the insert operation element will come into picture. Delete operation, you can either return the element or you can print it in the function itself. Okay, as we have done in the pop function of the stack, we have done printing of the popped element in the function itself. So pop also doesn't return anything. In that case, element becomes non-useful contender in many of the cases. Only when you are doing insert operation, element will come into picture. That's why I don't include that as a member of the structure. Srinivas, I think I have answered your question. Yes, thank you. Okay, any other doubts? If not, we will proceed ahead. Please let me know. Can I proceed ahead? Okay, guys, thank you. Now, let me take an example, okay, of an ordinary queue. And can anybody tell me what may be the drawback of this ordinary queue? Can anybody comment? You can unmute and go ahead. Yes, guys. What is the drawback of ordinary queue?
Ma'am, after deletion of the
Yeah.
reset the front value to 0.
Okay, after deletion, though
We are
the
not
places are empty, it shows that queue overflow. Okay, let me just explain that part so that you can understand very conveniently what is the drawback of this. Yes. Okay, you just imagine that my queue contains right now 5 elements, 10, 20, 30 and 30, 40 and 50. Now quickly can you comment where will be front, where will be rear? I'm waiting for your comments in the chat. I want both the values. Where will be front, where will be rear? Ananya, you have given me only front value. Okay, F0, R4, correct. All of you are correct. So front is at 0 and rear is at 4. Now at this point, I will delete this 10. I'll delete 20. I'll delete 30. Where will be front, where will be rear? Quickly. Front 3, rear 4. Okay. Front 3, rear 4. Now can I insert a new element, say 60. If I try to insert a new element 60, will it allow me? Where the insertion has to happen? In the linear queue or queue? Where we have to insert the new element? Obviously at the rear end, correct? All of you are right. So, can I insert the element at this point in time? You cannot. You cannot. Though there are places for the new entrants, the ordinary queue doesn't allow the new element to enter into the empty places, though they are available. It is just because the front and rear are moving ahead of the positions where the element can be inserted. So how can I come to a conclusion that linear Q can be discarded in totally? Can I take a conclusion something like that? No. What is a way out? How I can make sure that I will make this linear Q work according to this, so that whenever places are available, those places can be reutilized. How I can do that? I can do it like this. Let me just draw it and show you. What I will do is, I will make this rare to revert back to the available positions. It means what? The last element gets wrapped with the first element. It as if looks like this bangle. Okay, the bangle which I am wearing, it looks like this. I will arrange the elements in according to the circumference of this circle. Okay, this is called as circular Q. It is an improvement over the ordinary Q. So you have imagined the ordinary Q in the horizontal direction. You have to imagine the circular Q in the same manner, but only thing is the last position element or the last position is connected to the first position. Okay, so when you just hold this bangle, if my first element is available here, second here, third here, fourth here, you just imagine it is news, north, east, west, south. 4 elements are there. Now what I will do, I'll remove this northmost element and I will remove this side element. Only 2 remaining are there. What this last element does, this last element, it will hold the address of 0th position. It will hold the address of 0th position, or rare can be made to move back to the 0th position. This is what is the improvement over the linear Q. And this is how a circular Q is better than the linear Q, because I will reutilize the positions of the elements which were not done in the linear Q. Whether this is clear for you? How it has to be done, that we will see. Okay, how it has to be done. At least this kind of modification to the linear Q. Have you understood this? Please comment.
Ma'am,
Yeah,
ma'am, after
yeah.
deletion of that,
Pardon? I'm not able to hear you properly.
ma'am, after the deletion of the front value, ma'am, like
Yes.
ma'am 0, can't we swap back the numbers like 20 to 0th value, then 30 to 1th?
Okay. Praveen, it's a good point that you have told, but imagine there are 1,000 elements and you are supposed to move 1,000 elements every time. You just imagine the kind of complexity that is there. This is a drawback of arrays. That's why we go for what is called as linked list. Okay. Next chapter is your linked list. Lovely data structure that is available for you. Okay, see, you just imagine like this. You have deleted the first element, 0th position element. I have 999 elements ahead. Can you think of shifting those 999 elements one position before? Can you think of? Imagine there are 1 lakh elements. Is it feasible, Praveen?
No, ma'am.
No.
Time.
Time consuming. Nowadays, memory is not an issue at all. You will get memory in this small chip. Okay, terabytes of memory in this small chip. But what is more important for you? The most important part is time. How quickly I can get my things done. Okay, time is having more importance than the memory nowadays. Because even you, when you have this dirty thing available in your hand, mobile, on click of an app, it should open. If it doesn't open, you'll start hitting on your mobile. Okay, time is very important. That's why you can't think of shifting the elements. That's a wrong idea for the current scenario. Okay, so all of you agree that there is a requirement of an improvement over this linear Q. Now, how I can make sure that I will wrap the rear back to 0, and similarly how I can wrap the front back to 0. Can you think of this? Can you think of this? I'll give you 2 minutes of time for telling me the answer for this.
We can reverse, ma'am. There.
You can reverse. See, the person whoever gives me the correct answer, I will invite you for the tea. Okay, of course you are not available in the college. Whenever you come back to college, you join me for the tea. Okay, tell me. Any other guesses?
Ma'am, when the queue is full, reinitialize both the things. Ma'am means the
Reinitialize
rear of,
front to 0 and rear to -1.
yes, ma'am.
But if you do that, 40 and 50 are still available.
Okay, ma'am. Then deletion must have to be done and then reinitialize this.
So that is a restriction that you are giving. I call it as input restricted queue. Okay, that we will discuss later.
Okay, ma'am.
Okay. So any other guesses from any other people? When size is full, start rear again from 0. That's what I talked about. Okay, how I can, okay, Vivek, tell me how I can start the rear back to 0.
Maybe initialize it to 0.
You'll initialize it to 0 explicitly.
Yes, ma'am.
How about front?
Ma'am, front will stay in the same value as it was, and if rear reaches to front
Ek
minus.
minute, ek minute, Vivek. Okay, listen
Yes,
to me.
ma'am.
What I have done, I have inserted 60. Okay, I have
Yes,
inserted
ma'am.
70. According to you, I will do that. Okay, I will reset the rear to 0. Then rear gets incremented again. So 60 and 70 are there. 30 is not there. This is empty still. Okay, now what I will do, I'll delete 40. I'll delete 50. Okay,
Okay, ma'am.
where will be front and where will be rear? Of course, rear is at this position. I agree. Where will be front? Any
Yes,
comments?
ma'am. It will be a problem.
Yeah. Okay. So any other solution? Any other
Ma'am, we
solution?
can apply a loop with the instruction that front equal to rear. Then
Yeah.
front plus equal to minus minus, ma'am.
Okay. Nice. Without any conditions. I don't want to use any conditionals. Then, okay. Let me give the solution. Fine. All of you are ready for the solution, or you want to try once again?
Minute, ma'am. Please.
Okay, ठीक है. So you are giving up the tea offer. Fine. Okay. So let us just imagine that, guys, I have 5 minutes of time left out in this class. Anyways, you'll be joining back for the class. Can you take 5 minutes of time without Googling up? Okay, without Googling, no seeing of the Google. Can you try for another 5 minutes, 5 to 10 minutes? After 10 minutes, you have to join back. Okay. Can you try after 10 minutes and try to tell me what is the solution for this? Let us have a bit of secrecy for this. Okay. In the next class, I will be taking only for 15 to 20 minutes. In the next class, please come back and give me the solution. If not, I will give you the solution. We will break for 10 minutes. Okay. Thank you all. Please think of the solution. Don't Google.